In today's video, we are going to go over when limits do not exist. Welcome back to my channel, Numerics with Nadia, and let's get into our lesson objectives for today. First off, we want to identify situations where a limit does not exist. Then we'll get into the difference between a jump versus a removable discontinuity. Then we'll work through infinite versus oscillating discontinuities. And then, as always, we'll go through some practice examples. If you guys haven't watched my most recent videos on understanding limits, the introduction to basic calculus, or the one-sided limits video, I would highly encourage you guys to watch those two before getting into this lesson. I will link them here for you guys. And let's get into a quick review of when limits do not exist. So as a review, we have two notations here. We have the limit as x approaches a from the left of f of x and the limit as x approaches a from the right of f of x. When a limit does not exist, these two don't equal. So a limit does not exist when the left limit, the limit as x approaches a from the left, does not equal the limit as x approaches a from the right. When this happens, we would say that the limit does not exist. And the notation you can use is just DNE as a quick abbreviation. And now that we have reviewed that, let's get into jump versus removable discontinuities. What is a jump discontinuity? A jump discontinuity occurs when the left-handed limit and the right-handed limit, they exist, but they are not equal. So for example here, if we're looking at our function, we have f of x equals 1 when x is less than 0, and f of x equals negative 1 when x is greater than or equal to 0. So we can see here that the limit as x approaches 0 from the left is 1, and the limit as x approaches 0 from the right is negative 1. So they both exist, but they are not equal. So that means that the limit does not exist due to the jump. Now let's compare this to a removable discontinuity. A removable discontinuity occurs when the limit exists, but the function value is either missing or different from the limit. So if our function here is x squared minus 1 divided by x minus 1, when we go through and factor the top, what ends up happening is that x minus 1 on the denominator will cancel out, and our function simplifies to f of x equals x plus 1. But because we canceled out that x minus 1 top and bottom, that means our function is undefined at x equals 1. Therefore, there is a hole at x equals 1. So the limit as x approaches 1 of f of x is 2, but there is a hole, but it is a removable discontinuity. Now let's get into our next two. We have infinite versus oscillating discontinuities. An infinite discontinuity occurs when a function grows infinitely large or infinitely small near a point. So here our function is 1 over x, and as x approaches 0, from the left-hand side we're approaching negative infinity, and from the right-hand side we're approaching infinity. So because they're growing infinitely small and infinitely large, they do not exist because of this vertical asymptote. So that is a infinite discontinuity. Now for an oscillating discontinuity. An oscillating discontinuity occurs when the function oscillates without setting any value at x equals a. So looking at the function of sine of 1 over x, if we look at our graph, there is no consistent value as x approaches a. It oscillates between 1 and negative 1. So because of this, this would be an oscillating discontinuity. Now that we've gone over all of our definitions for today, let's get into our practice section. For number 1, our function is f of x equals 1 over x minus 1 squared. And let's say that we are looking for the limit as x approaches 1 of f of x. So looking at our function here, the limit as x approaches 1 from the left, we can see that it is approaching infinity, right? Our values are getting larger and larger and larger. Now, looking at the limit as x approaches 1 from the right of f of x, it actually ends up doing the same thing. So the same way our pink arrow is growing and it is approaching values that are getting bigger and bigger, like our limit as x approaches 1 from the left, it's doing the same thing on the right, and I'm showing that with the green arrow here. So we see that the limit as x approaches 1 from the left and the limit as x approaches 1 from the right are both infinity. So the limit as x approaches 1 of f of x here would be infinity. However, this is one of the examples we've already looked through today. The limit will not exist here because the limit is infinity. And why is that? That is because of the infinite discontinuities that we already went over. So this was our first practice example for today. We'll go through one more just so you guys can see how we apply what we have learned. For number 2, our function is f of x equals x minus 2 times x plus 1 divided by x minus 2. And for this one, we're looking for the limit as x approaches 2 of f of x. Looking at our function, we can cancel out both top and bottom, that x minus 2 term. When we do that, our simplified version would be f of x equals x plus 1. However, since we canceled out that x minus 2 term, that means that x cannot equal 2. Now that we've simplified the function, let's get back to trying to find the limit as x approaches 2 of this function. So we have our line graphed here. The main thing that we need to keep in mind is since we took out that x minus 2 term, top and bottom, that means that there is a hole at x equals 2. So when we look at our graph, the limit as x approaches 2, we can go from the left, and since our graph here is a line, we can very clearly see that it approaches 3. So the limit as x approaches 2 of f of x would just be 3. However, there is a hole at x equals 2. So what we will do here is we would just say that the limit as x approaches 2 of f of x, the limit exists. However, there is a hole. And what type of discontinuity was that? That would be a removable discontinuity. So that wraps up our practice questions for today. I hope you guys enjoyed today's lesson. I know it was very in-depth, so if you guys have any questions, please feel free to comment them down below. Please subscribe if you haven't already. Comment any questions or any other video topics you would like to see, and I will see you guys next time.